right, so this is our chemical reactions lab. And so you want to make sure that you open up Classroom and find your lab sheet. So you'll find the assignment called Chemical Reaction Rates Lab. You will see it has experiment 1, 2, 3, and 4. So for this assignment, not only will you be doing the Edpuzzle to get set, but you will also be completing this as you complete the lab. So you'll be doing observations before and during, and then answer 3 questions after the lab. And there will be times when in the Edpuzzle what prompts you to do that. And then you have here for experiment 2 the same thing, and 3 and 4. Okay, enjoy. Hi guys, it's Mrs. V. We're doing our experiments for you, and I have my 2 little helpers here. I've got Jace here, and I've got Josie. So they're going to help me do these. There's one of them that I can't do, but we definitely are going to do everything we can. All right, so for the first one, make sure you've already put your boxes in your notebook. If you haven't done your boxes, go ahead, pause the video, do your boxes, okay, for each of the experiments. Now, it's going to be also on page 76 and 77 of your notebook. What you're going to do is you're going to watch this video and fill in. So the first thing is we are going to run experiment 1. And we're talking about temperature and how that affects the chemical reactions, okay? So we've got our 3 glasses of water. We've got hot, warm, and cold. And we have our 3 glow sticks here, which will start in a minute. Yes, they're all yellow, okay? So what I want you guys to do right now is I want you guys to pause the video for a minute. I want you to start filling in what does it look like before. We're going to crack these and show them to you, and you guys are going to fill out. So go ahead and crack that one, Jace. Crack that one, Josie. Because when we crack them, we are already going ahead and we're starting that chemical reaction. Okay? And so if you notice, they start glowing. And that's because there's a chemical reaction happening. Okay? And so we've got that started. So this is, if you notice, guys, hold them up to the camera for me. They're all kind of the same. They're all yellow. So you can make your observations before. So you can already go ahead and make your observations before. The next step, okay? So make sure you're doing that. Okay. I'm assuming now you've made your observations. So now what I want you to do is I want you to answer A. So what effect do you think temperature will have on what you observe? Okay, what do you think the temperature is going to do on the chemical reaction inside these glow sticks? Increase it, decrease it, keep it the same, do something. And if you think there's going to be a change, which temperature will make the glow stick brighter or increase the reaction? Hot, warm, or cold? Which is going to make it better? Okay, so go ahead, take a minute. I want you to make your prediction for A. Okay, pause the video. All right, welcome back. Now that you've done that, what I want you guys to do is start watching. So we're going to go ahead and put our glow sticks in just a minute. Okay, Jace is going to put his into the hot. I'll put mine into the warm. And Josie, I want you to put yours
in the cold.
Cold, not your mouth. All right, here we go. 1, 2, 3, and go.
Tamale.
So there we go. So we're going to watch these for a minute as they're in hot, warm, and cold. Okay?
I go get a snack.
And so you can start seeing what's happening to the chemical reaction or how bright these are. Okay? So you should be making your observations in the observations during box for hot, warm, cold. Okay? Okay? Hot, warm, cold. And hopefully this paper is helping you guys see which one makes it glow brighter. Okay, and after you guys do your observation during, then go ahead and answer B. What does the temperature of the reactants have to do with the motions of the particles? Which remember our heat and energy transfer from our first semester? What happens when you heat things up? What happens to the motions of the particle? Do they go faster? Slower? Remember going from like when we did the ice lab, when we did from going from ice to gas, okay? Were the particles going faster or slower, okay? So hopefully you guys can kind of see now. We'll take them out in just a minute. and we'll kind of put them next to each other. All right, guys, are you ready to help?
Mm-hmm.
All right, put your tomato down there, Jace. All right, Jace, you're going to grab the hot. We're going to put them right in front of the glasses so they can all see, okay? Well, actually, we're going to move the glasses out. So go ahead and grab your stick. Josie, grab the cold. Jace, grab the warm. I'm going to put the warm in the middle. We're going to move the glasses kind of out of the way, okay, for you guys. And then go ahead and stick them right next to each other. Can you put yours right next to mine? So you see how bright Jace's is. Josie, move yours in to mine. And how light Josie's is. So the Jace's right here, that is right here,
Mom's
is the hot. This is the warm, and Josie's is the cold. Okay? So make sure you're answering our questions. All right, thank you guys. All right, so that's the end of experiment 1. So okay, so here is our experiment for surface area. So we have 2 pieces of chalk. It's the same chalk. I've just snipped them in half. And so you have one side that's not crushed and one side that's crushed. So which one has the higher surface area? The whole or the crushed? I hope you said crushed, okay? So crushed has a higher surface area. So what is your claim? Do you think the reaction between the vinegar and the chalk is going to be higher in the whole chalk or the crushed chalk? Where's the rate of reaction going to be higher? All right, so here we go. So you should have already made your observations for before of what this chalk looks like before, what this one looks like before. So you should have your observations done. And now you can see the during. So I'm just going to add a little bit of cider vinegar just to cover the chalk. So any vinegar works, but I'm just going to go ahead and cover up the chalk there. Okay, and then I'm going to cover up so you can see there's a little bit of a reaction happening right here at the edge of the chalk. You see the bubbles. All right, let's go ahead and put it in the crushed and let's see. So this one, as you can see lots of bubbles. And I'm going to kind of swirl it around so it gets to the bottom. But you can see a lot of different reactions happening here. You can see, I can see, if you can see, there's lots more reaction happening over here. The chalk is definitely dissolving a whole lot more, as you can see when I stir it a little bit, because that's one of the things to make the rate of reaction go faster, right? You can see it foaming up because the reaction is just here on the surface here, but it has more contact over here with the chalk. So you can see how then whoop, we can increase that reaction by a lot. Okay, so which one do you see? The rate of reaction, where are bubbles? How many bubbles we had? Was it higher in the whole or the crushed? All right, so that is, and hopefully you said crushed because I can even see it dissolving all of the little things. You can start seeing it kind of make all those bubbles as I stir it a little bit. Okay. Mix it a little bit more so that they have those higher colliding with each other, the atoms, okay? All right, so that is your experiment of chalk and vinegar. Experiment 3. All right, so experiment 3 is about concentrations and how that changes the rate of a reaction, okay? So make sure you've done your table. If you have not done your table, please pause the video and do your table in your notebook. Okay, so what we're going to do, I know it says 2 glass bottles, but I went back yesterday, and I got our test tubes. This is the way I was going to have you guys do it in the classroom. So I have 2 test tubes. Is that good?
Yeah.
I have two test tubes. I have one here that is a half water, half vinegar. Okay, and I have this one here, which is full vinegar. And we're going to do a chemical reaction where we're going to add baking soda. Josie and I filled 2 balloons with baking soda. And the chemical reaction is vinegar plus baking soda makes carbon dioxide gas. So we're going to see how different concentrations of a reactant, because we have one reactant is baking soda, the other reactant is vinegar. So if we change the concentrations of one of the reactants, how does that affect our chemical reaction? Does it increase the products? Does it decrease? What happens? So this one has less reactants because we only have half the vinegar. So is that going to produce less products or more products? And the same here, we have a full, so we have a higher concentration, so more reactants. So is this going to produce more products or less products? Okay. So what I want you guys to do is you're going to go ahead and you're going to start by answering your A. So answer your A question, make your prediction, which reaction is going to happen faster. So is it going to be the lower concentration or the higher concentration of reactants that's going to make the reaction happen faster? And why do you say that? So pause the video, answer, and predict for A. Would you stop? Goodness gracious. Okay, so I'm going to go ahead. You should have answered A, but we're going to go ahead and put our balloons on, and we're going to make our reaction start. Josie, do you want to put it on this one?
Yes.
Okay, so the green one is going to be the higher concentration, and the blue is going to be the lower. So please don't break the test tubes. Okay, don't dump it yet. Just remember, put it over the mouth of the test tube, but don't dump the stuff in yet. Okay, so just like that. Can you do that?
Difficulty.
It is difficult. So if you're having an issue, let me know. I'll hold the test tube for you. There you go. I would probably holding all your test tubes too. All right, so we're going to put that in. So there's our higher concentration and green and our blue lower concentration. Are you ready, Josie?
Yes.
Dump them in. So we're going to dump them in. We're going to see what
And then shake it.
happens. Okay, here we go. So this is a lower concentration. This is a higher concentration. So which one is happening faster? Don't give them the answer now. And we're going to give them a little shake. We're going to make some of this stuff happen. Josie, just give it a little shake, a little stir there. Okay, put it down. So you can see, hopefully, that the green balloon is a little bit bigger. Okay, so this one had more products producing. It's producing a little bit. It's actually stopping right now.
Is it warm?
I don't know. Is it warm?
I don't know.
You can touch the test tube. Nope, it's cold. It's actually a very cold test tube. Okay, so now that you've seen this, okay, feel that? It's cold, huh, Jace? What do you
Usually
think?
it's
Is it
warm.
cold? What do you think?
Usually when you
Like,
do
you
this,
feel
it's
cold.
warm.
Nope, it's
Like-
cold. Yep, it's cold
Oh,
today.
Chilly.
So, which reaction had the fastest rate? And I would say
That would.
the green one. It happened faster. Why? So, why do you guys think that? That's question B. And then C, why are higher concentration reactions faster than low concentration? So, that's your answer to C. So, answer your questions, pause the video. Go ahead and answer those questions because we are going to head outside to do something a little messy.
It's called elephant
Okay.
toothpaste.
So we're going to go and do this catalyst one. I'm going to set, you can watch
What the heck
me.
is catalyst?
Stop talking. We are going to go over and get this ready, but make sure you're got all your questions answered, and we're going to move on to experiment 4. And you guys are going to see what the catalyst is, okay? And you get to watch me kind of start to make it. All right, guys, so I've already just kind of set it up. I sent the other two. I sent Josie and Jace outside. But we're going to do experiment 4. After that, what I want you to do is I'm going to take you out there. You're going to see it's very messy, so it's done out in our backyard. And you're going to make your observations before and then during. There are 2 bottles out there. They have the same thing in the bottles, okay? The blue one has hydrogen peroxide, higher concentration than you can buy at the store. But you can still do it if you want to try it at home. It's just not going to be as reactive. So you got hydrogen peroxide and soap, just dish soap, mixed in there with some food coloring. The blue one is going to have cold water with yeast and cold water mixed in just a minute when they dump it. The red one will have the warm water with the yeast, okay? So, of course, the first thing I want you to do is make your prediction. Okay, so A, which will have a faster reaction? The one with warm water and yeast or cold water and yeast, okay? And then you're going to answer B and C after it's done. All right, so you guys go ready to go see. It's called Elephant Toothpaste. You can try this at home. You're just not going to be as messy. Okay, so here we go. I'll see you out there. All right, guys, here we are outside. We're going to try this. So this one right here is going to have the warm water because it's red. And this one will have the blue. This is blue water. So this is going to have the cold water. So they're going to mix in the yeast and the water. All right, guys, go for it. Hold the bottles once you put it in so that they don't tip over, guys. Go ahead. Well, this one was the warm water. So that they were switched. This one is the warm water that I'm actually holding. Okay, so you can see this reaction, how fast this is happening. Okay, Josie's over there is.
You have to wait.
So you can see why we did this outside, guys, because this is elephant toothpaste. It makes a mess. Josie's really trying to get hers to start. Let's see. I think they mixed them up, but that's okay. So you can see if we kind of shake Josie's. Now we're getting something to start, Josie.
Yeah.
Oh, there we go. But you can see the one with the warm water most definitely cause this reaction to really happen and just go crazy. Okay.
It's still going.
And you notice Josie's is happening, but it's happening really slow. And it's not as fun because it's just not making. Of course, Josie will probably shake it up in a minute. But if you look, even with this one, you can see, look how fast it is. I mean, there's hardly anything left in this blue one.
I can put
And
it.
there it is. Okay? So, fill in B and C. Hopefully you guys will see how this all works. All right, guys.
No, Mom, look at this.
We'll
Look at this,
see
look
you
at this.
later. Bye.